بعدين نشرح عن red blood cell كجزء من total blood، كجزء اللي هو formed elements. Formed elements they are formed mostly in the bone marrow from stem cell وصفناهم. And we end with red blood cell when we talk about erythropoiesis process, because we are talking about formation of red blood cell. نرجع نشوف الصورة هاي. So we are talking about this is the stem cell. From this stem cell we have this pathway for red blood cell. آخر شيء امبارح حكيت عنه أو أول امبارح إنه we are talking about ماشي بالعكس. We are talking about formation of huge number of cells. So we need more number of cells. And حكينا around 5 million cubic millimeter. To have more number of cells, we must have very dynamic DNA, RNA process. So we need regulation, we need raw material. And the end product of these cells, they lack nucleus, they lack mitochondria, the plasma reticulum. Why they lack that? Because we have to fill to replace that by hemoglobin, and the hemoglobin is the carrier for oxygen. And the criteria of this cell is rich in enzyme, certain enzyme, because it has a certain time period for its function. What's the criteria of this cell? These mature red blood cells. إيش ميزتها اللي أنتجناها؟ we have more cells حكينا. We lost all or almost all organelles, but we produce certain cells. They are capable of metabolizing glucose because we need ATP. So we need that. They're essential for transport of ions for that cell. So to maintain that capacity, and we have certain enzymes for certain period of time. And we have to prevent oxidation of protein in hemoglobin to keep it in certain form to allow binding oxygen. And take home message at the end of the day, we have stem cells, we need byproduct. We have certain processes. The byproduct, the aim of this byproduct to carry oxygen. So the function of that to carry oxygen. Now oxygen concentration in the blood, in certain tissues, will feed back on this process. How it will feed back on this process? By certain mechanism to produce certain regulator. So we have that concept. We have feedback, supply oxygen. Oxygen will control the whole process of synthesis. But what else controls the whole process of synthesis? The raw material. We need the raw material. What else? The DNA, RNA process, regulation of that, the activity. So we will think in these few words: synthesis, function, regulation. نعرفناهم كلهم. آخر 6-7 سلايدات ما راح أشرحهم، بنفكر ضمن هذا الكونسيبت اللي موجود عندنا. نيجي نكمل إيش اللي ساعدنا. So what we have erythropoiesis process, and this hematopoietic stem cell وصفناها مرة من شوي صغيرة to form this red blood cell. What is the function of this red blood cell? For tissue oxygenation. حكينا في other function to form carbonic acid in terms of acid-base balance. At the end of the day, this tissue oxygenation, if we have decrease in tissue oxygenation, how we have decrease in tissue oxygenation? If we have less hemoglobin, if we have less blood supply, if we have less oxygen delivery from outside through the lung. So any time we have less oxygen due to any cause, low blood volume, because the less amount of cells, or anemia, less amount of hemoglobin, or we have low amount of hemoglobin, anemia, another form, or we have poor blood supply to the tissues. Which tissue? From where we produce the regulator? As we produce that regulator, decrease tissue oxygenation, is especially in the kidney. We are talking about the kidney. If we have decreased oxygenation of the kidney due to any reason, it will stimulate this erythropoietin. And this erythropoietin stimulates the pro-erythroblasts to form the red blood cells. So we are talking about this kind of feedback mechanism to maintain homeostasis. Now, what is this erythropoietin? When it is formed, this erythropoietin is a hormone produced due to low oxygen supply to the kidney. It is produced in the kidney, so we have induced this low oxygen supply will induce what we call it a protein, due to hypoxia inducer factor, and it will stimulate this pro-erythropoietin. Do we have other sites to produce erythropoietin? Yes, we have in the liver, but mainly in the kidney. We are talking about 90% in the kidney and small percent in the liver. Do we have other regulators for erythropoietin? Yes, we have minor regulators, certain epinephrine, certain interleukins, they stimulate erythropoietin. Then erythropoietin, which stimulates the whole process of erythropoiesis. More information about this erythropoietin stimulates cell pro-erythroblast. Stimulate this cell pro-erythroblast. And this stimulation will promote release of reticulocyte. What is this reticulocyte? What is this reticulocyte? Erythropoiesis. During the process of synthesis, we have a cell, we lose all the organelles. We have certain remnants of organelles. When we stain them, they look bluish. And we call these cells as reticulocytes. What are these reticulocytes? It is the final cell just before it will be released from bone marrow to the circulation. So it is the youngest red blood cell in the blood. It is the final cell, the final structure, formed in the bone marrow, which is released in the circulation. Why it looks this bluish? Because we have remnants. Within 24 hours, this bluish discoloration will be removed. This material, nuclear material, basic material, will be disappeared, and we have the mature red blood cell. Now, how many of these reticulocytes? We have around less than 1%. ليش نحكي less than 1%؟ نرجع ببساطة. The lifespan of these cells around 100 days or 120 days. And daily loss, we have 1%. If we assume 120 days, لذلك اليوم تاني اليوم بعد 120 يوم, and so on and so forth. So the percentage of these reticulocytes is less than 1%. Erythropoietin stimulates the whole process to produce more reticulocytes. This reticulocyte production due to stimulation by erythropoietin, so it is detected. So if we inject erythropoietin, what we will see, we see what we will see. So red cell production will increase within 24 hours, and in the total red blood cell, we have this structure. طلع هاي سلايد ونرجع لسلايد السابق. So what happens if we stimulate with certain, this is about vitamin B12, material كمان شوية. It will stimulate the release of reticulocyte. نفس الفكرة. If we inject erythropoietin, we have a rise in the reticulocyte. What else we need regulators? ركبنا الأساس اللي هو stem cells to mature cells. حكينا الأسس. We have more cells, more activity, more division. We need other regulators. What are the other regulators? For DNA RNA formation, to produce the protein, which is the hemoglobin, we need another regulator, which is the vitamin B12 and the folic acid. So these two vitamins, they are essential for DNA formation, consequent maturation of these cells to produce a huge number of cells. We need more cells. قبل 3-4 سلايدات حكينا we need we produce more cells. What is the detrimental element of this B12? B12, we find it in meat, in certain food structure. To be absorbed, it's absorbed in the terminal area. We need a certain factor coming from the stomach, secreted from acid-secreted cell. We call it intrinsic factor. What is the value of this intrinsic factor? Gets bound to B12, and the complex will not be digested, and it will help absorption in the terminal area. So what happens if we have deficiency of this vitamin? The whole process will not take place, or it will be decreased. We don't have zero concentration. We have decline in concentration. What happens if we have decline in concentration? So these processes will be slowed down. What's the meaning if they will be slowed down? Simply the meaning, we will not continue this process in terms of activation. So we will keep cells with remnants, with the nuclear materials. So what's the criteria of these cells? Larger cells, contains the nuclear material, less space for hemoglobin, the junction destruction. We don't have the process of getting rid of the nuclear material. We don't get space for hemoglobin, and we have large cell with nuclei and this amount of hemoglobin. And the membrane criteria, the structure of the red blood cell will be weak. So at the end of the day, what's the meaning if we have little deficiency of vitamin B12? Simply we have less hemoglobin, معناته less oxygen supply to tissue. في تعريف بنسميه anemia, less oxygen supply to the tissues. And these cells are larger, they are nucleated, they have shorter T half-life. What's the meaning shorter T half-life? So we have rapid destruction of these cells. So instead of they survive 120 days, they survive 40 days, 50 days, whatever. So we have the rate of death over will be high. So we have anemia due to more destruction and less formation and less hemoglobin in these cells. Less hemoglobin in these cells. So these are the regulated, the needed material in terms of vitamin B12. So deficiency will have failure in nuclear maturation and cell division. We have large cells, weak membrane, and short T half-life. What else we need? This is شفناه. نرجع نعطيها كمان مرة. What happens if we inject B12? Usually, normally, physiologically, healthy individual, they should not have the chance of B12. Because we find it in nutrient material, meat, and other structure. We usually take it in many food. So what the cause of deficiency? Simply if we have stomach problem, intrinsic factor. We have terminal ileum problem, and we usually need 2 years to find the deficiency. So anytime we inject B12, immediately we will find a rise the reticulocytes. واتفقنا ان شو يصير ايش هم الريتيكولوسايتس اللي هم الفاينل ستيج final cells in the bone marrow just before they are released into the circulation. So we will find a rise in reticulocyte count, and with time we have rise in the hemoglobin concentration. هذول على regulation. كيف عن regulation? What about the raw material? What about the raw material? دور النيوتريشن نرجع نتخيل. We need many millions of cells. So we need raw material to develop these cells. We need to produce hemoglobin. So any nutritional problem will increase formation of red blood cells. نحكي بس عن الاسنشال element اللي بيهمنا حاليا. شفنا الاستراكشر تبع الهيموجلوبين المحاضرة الماضية. حنشوفه كمان اليوم. What we have, this protein structure, these chains, we have different chains, بالبايوكيمستري هشرح بالتفصيل. What concerns me now is the heme structure. And within this heme, we have the iron. So we need the iron. The iron is the site for oxygen binding. So oxygen is linked to the iron in the heme, And that heat should be part of the globin molecule as part in the red blood cell. So we need the iron, it's essential element. If we have deficiency of iron, if we have lack of iron, we have lack of formation of this heat, lack of formation of this structure, and less hemoglobin, and less capacity of this structure in terms of oxygen. So less oxygen supply to the tissues. The same story, we have to take iron. We need small amount of iron per day, and normally we find it in green vegetables, etc., and in meat and liver, etc., the nutrition of that sheet. What we need here, HCl promote absorption. Like نرجع للstomach, the cell which secrete HCl, the cell which secrete intrinsic factor, and both of them, they are essential for either a raw material for hemoglobin or a regulator for hemoglobin synthesis or red blood cell synthesis, vitamin B12. Now, how much we lose? On daily basis, we lose 1 milligram, but in certain cases, if we have hemorrhage, loss of blood to outside, or hemorrhage inside, and in female after pregnancy and delivery and menstrual cycle, we need more iron to have this amount of hemoglobin. So this iron is needed as structure, as essential structure element in the structure of heat to form the hemoglobin. طيب حكينا عن الأساس، حكينا عن regulation، عن component. ايش المشاكل الأساسية اللي ممكن تصير عندنا؟ ممكن يصير عندنا iron problem. نطلع على circulation of iron. How we have iron circulation, iron metabolism. Where is most of the iron? Most of the iron is stored in the red blood cell, is functional iron. So we take the iron from the gut, it is absorbed and transported through the gut, through the upper part of the small intestine, in all parts, but mainly the upper part of the small intestine, has to be linked with a certain molecule, apoprotein, to help in its absorption. And once it's absorbed in the circulation, it is carried by a carrier molecule, we call it transferrin, which is a certain form apoprotein, similar to another one, we call it ferritin chemistry. So what's the value of it? Of this will help in transport. Transport to be stored either in the liver, and most of the iron will go to the bone marrow to be essential part of the hemoglobin. But this essential part of the hemoglobin, the body will keep it, will not lose it easily. احنا اتفقنا وحكينا من شوية صغيرة life span of red blood cell 120 days. So we have destruction of this red blood cell. ايش معنى destruction? Destruction of the heat, the destruction of the globin. But what happens to this heat? Do we lose it? The body has a very good conservative mechanism for two ions, iron and iodine. When we talk about thyroid gland, we will repeat the same story. Iodine is recirculated, it will be reused again and again. Iron, the same story, it will be, once we have it in the circulation, and we have death of red blood cell, we have a شوية more detail, this macrophage system will break down the hemoglobin. We have the globin molecule will be broken down to amino acid and it will be cycled. And the heme, it will take the iron and it will recirculate this iron. This recirculation of the iron will preserve the iron. The iron will be kept in the body again and again, it will be circulated. So we have the story of iron, we have high conservative function, we protect, we prevent its loss, because we have small amount, usually we use around small amount of iron, 7 milligrams, 6 milligrams we have daily requirements, and in female we need a little bit more. Like, we have the iron, we preserve it, is transported as transferrin in the circulation and in the intestine also, and stored in the cell by a structure we call it ferritin molecule. So it is stored, around 1/3 stored in the liver, but most of it, around 60%, will be found in the as essential part of hemoglobin. طيب, lifespan of this red blood cell again انتهت, and we have destruction of this. نخلص من الآيرون نرجع للكومبوننت. So في عندي transferrin and ferritin. This is the carrier molecule, storing molecule. Like nature, iron, where we find iron? In hemoglobin as functional, ferritin as stored, and transferrin as transported molecule and transferrin. And we have very small amount of hemosiderin, and in pathological condition, with pathology أكثر, we have more and more hemosiderin in certain disease. If we have more destruction in certain hemolytic diseases, we have that. لذلك نرجع نركز على الآيرون and what happens to this. Now, نيجي نطلع هذا destruction. سحبنا. We recirculate. What happens to this structure? We have continuously high amount of this structure. It's a waste product. This is the only waste product. Like, if we destroy the red blood cell, the globin will be recycled, heme will be destroyed, iron will be recycled, this will be released and the body will get rid of it. In which form? ليش أنا بشرح؟ لأنه بهمنا لما نفكر الفانكشن الكلية إيش الباي برودكت؟ من الباي برودكت نرجع نشوف الأسس إيش اللي صار. يعني قبل ما أكمل نتخيل if we have lack of synthesis of red blood cell. مع بعض نفكر إيش بده يكون تركيز الهيموجلوبين بالسيركوليشن؟ lack of synthesis. المصنع خرب، البول مارو خرب. ايش بده يكون عدد الريد بلاد سيلز في السيركوليشن؟ بده يزيد ولا بده يقل؟ بده يقل طبيعي. ايش بده يكون تركيز الهيموجلوبين؟ بده يقل. من هاي الاشياء نرجع كمان شوي بنعيد في وقت ثاني. Now, if we have more destruction of red blood cell, what happens to the iron? It will be recirculated. But if we have more destruction of red blood cell, ايش الباي برودكت اللي بده يزيد عندي؟ حكينا. This is the one which will be circulated and released. So the destruction of this red blood cell, حكينا عن كل الكلام هذا، بس globin will be recycled, iron will be recycled. ضل عندي شيء اسمه bilirubin. What is bilirubin? What is bilirubin? Bilirubin is the byproduct of the heme. The heme molecule اللي هو كان في iron اللي هو non-iron component of heme. So the more we have destruction of red blood cell, the more we have production of bilirubin. Where it will go, this bilirubin? It will go through the liver, will be secreted into circulation. Some of it will be secreted through biliary secretion or liver secretion will come to the small intestine. Now what happens in the small intestine? Nurture. The circulation, the bilirubin will give the yellowish coloration of the plasma. ونيجي نطلع البلازما color. It is yellowish, pale yellow. It can be more yellowish or less yellowish. It depends. أي color بيعتمد أي حسب تركيز الداي والفوليوم تبع الصول. The more we have dye, اللي هو الكلر, the more we have the color. Now, bilirubin, once we talk about bilirubin, once we have more destruction of these cells, we will in more release of this byproduct. And more release of this byproduct, more color of the plasma, and more contents will come to the small intestine. نرجع نشوف الموديل كمان مرة. liver is the site of secretion of bilirubin. خدوا الاناتومي بتاعت الليفر؟ تعرفوا الاناتومي بتاعت الليفر؟ لا، ما نعرفهاش. From the liver, through the pathway, we call it common bile duct. بيجي على اسمها الانتستين. كل السكريشن بتاعت الليفر على الانتستين بتيجي خلال هذا الضغط. And secretion of the liver will go to circulation. So the more we have breakdown of red blood cell, we have more coming to the small intestine and more coming to circulation. So what will be the color of the plasma if we have more destruction? Become more yellowish. The same story if we don't have the bilirubin. When we don't have bilirubin, or we have low, physiology في شيء we have we don't have. We have more, we have less. مع إنه بغلط وأي واحد بيحكي we don't have. When we have less bilirubin, probability. If we have less red blood cells, when we have less red blood cells, if we have less formation of blood cells, loss of أهم من هذا الشيء when we have more yellowish, more bilirubin. When we have that, more destruction of cells. When we have more destruction of cells, if we have abnormality, if we have abnormality of certain disease, ما لناش الabnormality بتاخدوها بpathology. Any more destruction of these cells will end in more bilirubin. So it's a marker, bilirubin can be used. It's not essentially the only, but it can be used a marker of the status of red blood cells. نيجي نعتمد عليه. If we have destruction or loss of blood within the body, what will happen to the hemoglobin? Will be destroyed and will be recycled, كله recycled ما عدا في هذه probability if we lose blood to the outside the body. في الحالتين، الحالة الأولى فقدت blood لبرا، الحالة الأولى فقط مش مشكلة فقدت blood لبرا، الحالة الثانية صار hemolysis loss of blood أو hemolysis inside the body. كيف بميز هاي عن هاي من البيليروبين؟ نرجع نفكر فيها. انتوا فكروا فيها. مين بده يحكي؟ كمان مرة. I lost blood outside or I lost blood within my body. Within my body, what happens? Within my body صار عندي هاي العملية macrophages will destroy these cells and it will recirculate iron and will get rid of bilirubin. If I will lose it to the outside, what will happen? ولا شيء، طلع برا الشارع، طلع برا بالشارع. ايش معناته الكلام؟ The amount of bilirubin will be produced لو في الحالتين يعني فقط 500 ml داخلي 500 ml خارجي. في الحالة الأولى بده يزيد البيليروبين عندي الداخلي، في الحالة الثانية ولا بزيد ولا شيء. لأنه كل الهيموجلوبين كل الريد بلاد كل البلاد كومبوننتس طلعت برا. طيب من هذا العمل هلا نيجي لشغلة ثانية. بدي أرجع للليفر. حكينا في عندنا كومن بايل داكت. تسمعوا بالمرارة وحصبة المرارة. نسكر هذا المجرى. سكر المجرى اللي باخذ السكريشن الليفر سكريشن to the intestine. ايش بده يصير what is secreted from the intestine and should reach the secreted from the liver and should reach the intestine. ايش بده يصير فيه؟ بده يتراكم بالسيركوليشن. لكن البيليروبين ايش بده يصير فيه؟ البيليروبين mainly is secreted through the liver to the intestine. ايش بده يصير فيه عندنا؟ بده يتراكم بالسيركوليشن. طيب هل زاد البيليروبين؟ مش لأنه زاد عندي destruction of red blood cell. And getting rid of this bilirubin is interrupted. طيب هلا نرجع نشوف عدة تسميات من هذول اللي حكيت ما راح اشرحهم. في عندي certain anemias. What is anemia? State of lack of hemoglobin and or red blood cells below certain level. ما اشتغل بالليفل. دخل الارقام ما بدنا نحفظها مع الايام تيجي. How we can have anemia؟ نرجع نفكر في المدن. باختصار المصنع خرب اللي هو البولمر. How we have this failure in Borner? We have many conditions. الناس تخلف exposure to toxic drugs, exposure to X-rays. إيش اللي خرب المصنع؟ إيش بده يصير إنتاجية البلاد سيلز؟ بده يصير عندي أنيميا. في عندي genetic disease of certain to produce certain types of hemoglobin. احنا لما حكيت في عندي 4 chains of globin، في عندي 2 alpha 2 beta normal hemoglobin. We have abnormal hemoglobin اللي يشتغل فيهم هون. These abnormal hemoglobins ايش الكرايتيريا تاعها؟ اللايف سبان تاعت الريد بلاد سيل will be short. لكن صار short life span ايش بده يصير بالدستراكشن اوف ريد بلاد سيل؟ بده يزيد. ايش معناته؟ الهيموجلوبين ايش بده يصير فيه عندي؟ بده يقل. هي حالتين، الحالة الأولى كان مصنع خرب بس الإنتاج الكلي تناقص. الحالة الثانية جينيتيك ديزيز صار إنتاج بس صار هيموليسيس. طيب كيف بدي أميز هاي عن هاي؟ في الحالتين في هيموجلوبين بس في الحالة الأولى فيش عندي bilirubin formation أو عندي less bilirubin formation. في حالة المور هيموليسيس ايش بده يكون بالبيليروبين كونسنتريشن؟ بده عندنا يزيد. طيب نيجي للي شرحناهم الأربع نقاط: number of cells, size of cells, regulator, etc. etc. صار عندي كدني ديزيز. ايش يعني صار عندي كدني ديزيز؟ أو انشالت الكدني أو ايش بده يصير الفانكشن تاعت الكدني عندي؟ بده تقل. قلت الفانكشن تاعت الكدني ايش بده يصير بالإريثروبويت؟ بده يقل الإريثروبويت. ايش بده يصير بالهول بروسيس اوف إريثروبويسيس؟ بده يقل. Any kidney disease will interfere with the bone marrow formation function. Or if we have vitamin B12 deficiency وصفناها من شوي صغير. Or if we have folic acid deficiency وصفناها من شوي صغير. لكن لما بدنا نفكر lack of hemoglobin أو anemia, we have lack of hemoglobin and or red blood cells. يا إما the bone marrow failure، يا إما abnormal blood cells، يا إما more rate of destruction، or we lose blood. How we lose blood؟ any trauma أو rupture blood vessel etc. لكن بهذه الحالة بإمكاننا نشوف different kinds what we call it anemia اللي هي by definition lack of hemoglobin and or red blood cells. هلا نرجع لمواصفات أخرى الباثولوجيا حتوسع أكثر. بس بدي أشوف هاي الميجالوبلاستيك أنيميا. ليش محتملة الميجالوبلاستيك أنيميا؟ إيش ميزتها؟ وصفناها من شوي صغير. إحنا في عندي نورمال سايز للريد بلاد سيل. لما شرحنا الفيتامين بي ديفيشنسي ايش حكينا ميزة السايز؟ ايش بده يصير؟ أكبر. ايش ميزة السيل؟ نيوكليتد. ايش ميزة السيل؟ فراجايل. عشان هيك بنسميها ميجالوبلاستيك أنيميا. لكن في عندي تسميات مختلفة تعال الباثولوجي حيركز عليها أكثر. بس بيهمني نفكر من physiological point of view how we think يعني how we start to build up certain model on certain information أخذناها خلال المحاضرة الحالية from the synthesis to the production of red blood cell and the metabolism of metabolic process. طيب نيجي للإكستريم الآخر. الإكستريم الآخر إيش الإكستريم الآخر؟ حكينا. نرجع للسلايد هاي، نرجع لها كمان مرة. What we have decreased oxygen. We have decreased oxygen. What will happen to electrolyte will be stimulated to correct. Imagine we are living at high altitude. We are living at high altitude. إيش بده يصير في البيوت؟ إيش بده يصير في الأكسجين؟ الأكسجين percentage إيش بده يصير فيها؟ تعريفين percentage partial pressure و كبرسنتج بتضل زي ما هي، بس الأكسجين partial pressure طبعا بده يتناقص. مش معناته صار الأكسجين سبلاي اللي هو البلمونري مش ديزيز، نشيل كلمة ديزيز، البلمونري سبلاي اوف أكسجين بده يصير less oxygen supply. لما يصير less oxygen supply from the lung مش لأنه اللنج خربت، لأنه الاكسترنال سورس تبع الأكسجين تناقص اللي هو الأتموسفير اللي بيطلع على الجبال العالية. مش بده يصير عندي less oxygen. These individuals, this oxygen بده يؤدي إلى more erythropoietin. More erythropoietin إيش بده يصير في red blood cell deformation؟ more and more formation. لكن بدون ما نحكي عن الديزيز هدول، if we have less supply of oxygen from outside خلص بصير عندي ايش بنسميه البولي سايتيميا. خلص هدول حكاية السلايدات فكروا فيهم بناء على والبولي سايتيميا شرح الكلمتين هدول، فكروا فيهم هدول بناء على سلايد هاي. أول سلايد بدأنا فيها آخر شيء حكيته المرة الماضية بناء على هاي السلايد. لا بناء على هاي السلايد. يعطيكم